Okay, first I'd like to thank all of the participants today. There are several of you, if I named all of you, it might take another half hour. But I want to let the members know that these are the names, I believe, of the range resource folks that are here this evening. I do recognize some of the names. And I believe we're going to get right into the presentation if we can, because I believe we're going to have a lengthy evening here. So we can sit back and allow range resources to present themselves and give us their presentation. John?
Thank you. We're going to talk about the lease, but we'll also talk about the business in general, the Marcellus Shale, who Range Resources is, and where we think we're going. The topics I want to cover are the big picture. This is the Marcellus Shale and the shale gas revolution. Local activity in northeastern Allegheny County and southern Butler County. Who we are, Range Resources, our operations, and why you would feel comfortable if you do decide to lease with us operating. Deer Lake's lease plans, what we would propose early on to start the activity. Water management. We're going to talk about water management a little separate than all the other operations, or hit upon special. The Environmental Defense Fund, and we'll talk about it in the presentation, considers wellbore construction having been solved in Pennsylvania. Pennsylvania has best practices regulations for that. There's two places that we can have groundwater contamination. One is the wells leaking themselves, and the second is by spills. So we're going to talk about water management because spills clearly is a concern. That'll be Pete Miller, our manager of water operations, talking about that. Safety and environment will be Steve Johnson. He's our director of HSE, Health, Safety, and Environment. And then at the very end, a few comments on the lease itself by Barry Osborne, who was here last week. This is the Marcellus Shale. On the map, you can see in the maroon is the producing wells. According to the EIA numbers, there's over 400 producing wells in the Marcellus Shale already. In addition, there's over 2,000 wells that are in some form of activity, either permitted. In Pennsylvania, the permit is only good for 1 year. So they're newly permitted, or they're actually drilling, or in some stage of completion, or they're waiting on a pipeline. So we're talking about quite a few wells that are active, some producing, most producing, but others. If we look at how much gas the Marcellus Shale produces, it's currently, according to the EIA, at 14 BCF a day, billion cubic feet. When you look at your statement from the gas company, you buy gas at 100 cubic feet at a time. This is billions of cubic feet. That represents 1/5 of all the gas being consumed and produced in the United States. So it isn't a question, is the shale gas revolution here? It is. And this area is providing 1/5 of all the gas in the United States. We've got before you 154 studies as part of your ability to do due diligence. We will give you the ability, the contact information through the internet, how to get the addresses. You can download the PDF just as well as we did. It includes the recent studies. It's both the good, the bad, and the middle. We included fracking by the numbers, key impact of dirty drilling at the state and national level by Environment America. American Gas Association, energy analysis, clearly an industry study. And then National Energy Technology Laboratory. These are just 3 examples, so they're industry, they're governmental studies, they're academic studies, and they're environmental group studies. But the vast majority say that fracking, producing shale gas, natural gas, is a safe operation when done under the right rules and regulations. And I would contend that Pennsylvania is one of the leading states on those rules and regulations. Now, based on those studies, we have a number of quotes. In fact, we have over 100 quotes here from different folks, federal, state, academic, policymakers, regulators, quite a few. The one I've got blown up on the slide on the presentation is from President Obama. We produce more natural gas than ever before, and nearly everyone's energy bill is lower because of it. The boom has led to cleaner power, greater energy independence, and we need to encourage that. We should strengthen our position as a top natural gas producer. It not only can provide safe, cheap energy, cheap power, but it can also help reduce our carbon emissions. Carbon emissions went down because of more natural gas being burned in power plants. Economic impact is one of the questions we got asked to address. On a national level, on the average, households have over $1,000 more discretionary cash flow because of lower energy bills. Within Pennsylvania, there's almost 250,000 Marcellus Shale-related jobs, and that's for the PA Department of Labor and Industry. The average salary for these folks is about $89,000 a year. If you look at the average salary for the non-industry folks in Pennsylvania, that's almost $40,000 more than the average. So it's a well-paying industry. Range Resources has 500 employees, and we directly support another 5,000. So I go out to my drill sites and all the other areas. We're a general contractor. We do almost none of the work ourselves. We hire drilling companies. We hire water transfer companies. We hire companies that do the pumping services. We hire folks to gather the gas and process it. So 5,000 people through our subcontractors, and we've consistently invested $1 billion a year. If we look at the benefit to the Commonwealth in taxes, fees, Pennsylvania's collected $640 million in impact fees over the last 3 years. More than $2.1 billion in other taxes since 2008, all related to the Marcellus Shale. Industry has spent more than $1 billion on new roads and infrastructure, and Range itself has spent about $120 million. If you look at where we operate, we want to operate all the time, winter and summer. We're going to bring in a number of loads of sand. We're going to bring rigs in and out. The rigs are temporary. The sand is temporary, an industrial construction, if you will. But we're going to be producing those wells for a long time. 40 to 50 years is what our belief is. And so we want to be able to get in and out at all times, regardless of the weather. We put in good roads. Where we have to, we upgrade the township or county roads to be able to carry those kind of activity. We'll talk about the local activity. We already have a lot of activity right around Deer Lakes Park. This is nothing new as to activity in the area. It may be new for under the park that we're talking about, but not within the area of the park. The blue wells are wells that are already drilled and online and producing. The orange wells or red wells are the wells that have either been permitted or are currently drilling. The wells in this area are all Range. These two pads are within less than a mile of the park. This pad, you're going to see some activity on that, is we already drilled 4 wells. We're back in drilling 3 more, and the drilling rigs are already on site today. It moved in last week. We're drilling additional wells, and that's within 2 miles of the park. The dots are all the vertical wells. There's over 100 vertical wells in this area, and almost every one of them have been fracked. So fracking is nothing new in this area, and horizontal drilling is nothing new. These are XTO wells. These are Rex Energy wells. These are Rex's permits, and these are our permits in southern Butler County. The current activity I talked about is the Boulevard pad. Less than about 2 miles away from the park, there's an air rig on doing the vertical part of the drilling. You can see the gas production units from the 4 original wells that were on the pad. So we're adding more wells. Activity is ongoing in this vicinity. The shale gas revolution is here. In my opinion, or my idea, is that the council is being asked, do you want to develop the gas under the park? If you do, who would you like to do it? I would contend that, as you're going to hear, we're in the area and we make sense to be the one to do it and put the least strain on the park. Other folks could easily come in. But what you're going to see is that if they don't have places around that are drill from, the only way they can develop the park is to build on the park and drill from the park. We don't have that problem. So that's the local activity. The next thing is, who are we? Who is Range Resources? Well, Range Resources is headquartered in Fort Worth. We're listed on the New York Stock Exchange. We're a member of the Standard & Poor's 500 by our ranking financially. We're a $15 billion market cap. Through Range Resources, Great Lakes Energy, or one of our predecessors, we've been in this area for over 30 years. We look at how much gas Range produced last year. It was 343 BCF, billion cubic feet equivalent. That's taking the liquids, the oil, and converting them into gas equivalent. So 343 BCF for the whole year. Let me tell you something about Range. We were the company that discovered the Marcellus. We discovered it in 2004. In 2007, we introduced horizontal drilling. The original drilling was vertical, not near as efficient as the horizontal. In 2008, we began operations in Cross Creek. You're talking about drilling under Deer Lakes Park. We were physically in Cross Creek Park, and we are today. We've drilled many wells there, and you're going to see some pictures. That park has been helped out quite a bit from the revenue from the wells. In 2009, we drilled the industry's first Utica Point Pleasant test. You hear a lot about the Utica over in Ohio and the big play, new play is. We drilled the industry's first horizontal well back in 2009 up in Beaver County. We also started in that same year drilling horizontal upper Devonians. The Marcellus is at a certain depth, about 500 feet above is the upper Devonian shales. Most of those dots you saw on that local map are upper Devonian wells, but they're in the sandstones or the carbonates. They're not in the shale. When I went to school, everyone knew you didn't make a well in shale. You just didn't. All my textbooks say you go through the shale. Well, now we know different, thanks to George Mitchell with Mitchell Energy and his stick-to-itness from first try in '82 outside of Fort Worth until the mid-'90s when he pretty well cracked the code. Sitting in front of you is a sample of the Marcellus shale. So we're talking a black marine shale. It was deposited below the sunlight layer. It's been compacted over time, it's somewhat layered, and been dewatered. There is no water in the Marcellus. Any water we get from there is returning water from what we fracked. So in 2009, we pioneered large-scale water recycling. We recognized way back when, while everybody was using municipal water treatment plants to handle their water, we realized back then that that was not the future, that we had to come up with some other alternative. We went two paths. One was to talk to some crystallization plants in which we would evaporate the water, end up with salts, and figure out how we could use that salt for road salt or other use. That was one direction we were studying. The other was actually fracking the wells with the recycled water, with our produced water. In my industry experience, we tried that other places with mixed success, but more not so good as good. We were developing the Austin Chalk with horizontal drilling and fracking back in the 70s and the 80s. There's nothing new here with horizontal drilling. We would use fresh water, and we get much better wells than when we use the produced water that's salty. So salt dissolution was part of the stimulation for the Austin Chalk. Well, we ended up trying that, and what we found is it didn't make any difference whether we had fresh water a mix of freshwater and produced water, or 100% produced water, our Marcellus wells were essentially the same. Fantastic news. We canceled all further engineering on the water plant idea and said that's the way to do it. We're going to recycle the water. It has two benefits. One is the water we use to recycle doesn't go into any other system. At that time, it was going into municipal systems. The other benefit is whatever we use to recycle with is that much less fresh water we need to take out of a river or someplace else. So we pioneered, and we were the first company to be at 100%. And so we've been, ever since then, either at or very close to 100% reuse level. Some people think when I say recycle, we put it back in drinking water. No, we put it back into the wells as fracking. We get the water out of the wells, we put it in tanks, and we use it again to frack another well. And we can do that time after time. It isn't like motor or something else. Say, okay, how many times can you do it before you can't overhaul it anymore? This water is just fine. We just keep using it and using it. It's water. It does not wear out. 2010, we were the first company to voluntarily disclose fracking fluids. The first company in the entire industry. We got a lot of people knocking us hard in the industry for that. We looked at it and said, we have nothing to hide. Why are we getting on the bandwagon with everybody else? We'll tell you exactly what we're using in every single well. We posted that on our website. Since then, we posted it in Frac Focus. It's now a requirement. Pennsylvania was the first state to require the full reporting by the industry on that. There are other states that have followed suit, Texas and many others. But we were the first state to do it, and we were the first company to start it. There's no reason not letting everybody know what we're using. We completed the Ute well in Fraser Township, just overlooking, up on the hill, if you remember, overlooking the Allegheny Mills Mall in 2010. No problems there. In 2011, we implemented closed-loop drilling technology. If you remember the older wells, there was always a reserve pit. We would use that, we'd move water in and out of the reserve pit, and the rules and regulations were that you would dewater it, put some little cement or something else in there to stiffen it up, and just take the flaps, the plastic of the liner, fold it up. As long as you buried it with 3 foot of soil, that's fine. That was the regulations. And that's still the regulations for shallow well drilling. We implemented closed-loop drilling technology, said we're not going to do that. We're not going to have any pits on location. We're not going to have any of those kinds of worries. We're going to capture all of our waste products and take care of them. We're not burying anything whatsoever on site. In 2012, we initiated a zero vapor protocol for wet gas and super rich areas. That was the same time, as you remember, one of the 2 fires that have been in this area. There was a big condensate fire on flowback in Washington County. The DEP was concerned, as many people were, and they were concerned about the cause. We ended up showing them what we'd already done to solve that problem 6 months before. And then at the DEP's request, we ended up putting on education programs for all the other operators, how to get rid of that problem. We do not let any methane escape. None. It all ends up being captured. Now it has 2 reasons. One is safety. Safety for people around there. If there's no methane around escaping, there's no possibility of fire or explosion. Safety for the environment. But the other reason is, quite frankly, I'm greedy. If I'm going to produce that gas, why am I not going to sell it? Why do I let it get vented out in the atmosphere and I miss that chance to make some revenue off of it? So we ended up doing zero vapor protocol, and that became the standard for the wet gas area. We apply those same principles in the dry gas area. The area around Deer Lakes is dry gas. There are no condensate or other liquids with that gas. That gas is ready to go to your homes for your water heaters, furnaces, or stoves. The gas in the western part of Washington is not. It's rich gas and must go through a plant to get all the liquid stripped out before it can go to your house. And then in 2013, we ended up converting our whole entire fleet of trucks to CNG. And that year, we were the biggest single order for both Chrysler and Chevy. Half our trucks were Chrysler, half were Chevy. We bought trucks that came out of the factory ready for gas use, natural gas. I talked earlier about Cross Creek Park. Here's a picture of Cross Creek Park and the beautiful lake there. This is a real success story because we're not only drilling under it, like we're proposing for Deer Lakes, we drill on it. We have many pads on that park, scattered around the park. We're drilling under the lake, we're drilling under the dam, we're drilling under the area, the whole area. And as you've heard from those folks, those of you who went on the tour to Cross Creek Park, they are very happy with it.
We're sorry, your call cannot be completed as dialed.
Some members calling in.
So let's talk about our operations. Permitting. There are 58 laws, rules, and regulations we have to consider as we plan the well. I'm not going to read all those, but those 58 rules, regulations, and laws require 197 reports, and those are not single-page reports. If you look at the middle of the page in front of Barry, we stacked up the excerpts that just apply to our operations from those 58 laws, rules, and regulations. We haven't done the whole thing. We don't have room on the table for it. We've also, to Barry's left, you're right, stacked up all of the permits, paperwork that we have had to apply for the wells that are in Northeast Allegheny. Maps, plans, everything else. The items that are covered by the permitting, water management. Where are we going to get the water? What are we going to do with it? How are we going to handle it after we use it? Wellbore construction. I've got a slide on that later, but that's very important. Pennsylvania leads the nation on the proper design for that. Erosion and sediment control. We're going to build a place that may not be as big as a Walmart shopping center, but we're going to build a pretty big flat space to put all this operation, about 2.5 acres. But we don't want any sediment or runoff, silt coming off that location. So we're going to have erosion and sediment controls. Location construction, road use, waste management, emergency response plan. You'll hear some from General Johnson on that. Preparedness, prevention, and contingency, PPC plan, has to be prepared for every county. You have one for the area, for the operations we have in Allegheny County. Part of that includes every chemical that might be on location, not just the ones that are on location. Spill prevention, control, and countermeasures plan, and air quality, just to name a few. The first step after we build a location, and you're going to see from Steve's stuff, some building location and how we do it safely and take care of that. After we build a location, then we're going to drill. In this picture, I realize it's not so easy to see because of the size. That's all plastic liner. We put plastic liner down underneath the rigs and all the operating stuff. We don't want to have anything touching the ground. In Pennsylvania, if we have 1 gallon touch the ground of anything, it has to be reported. If it's fresh water and not 500 TDS or lower, it has to be reported at 5 gallons. So we can have fresh water from the Allegheny and it spills. If we've got 5 gallons or more of fresh water from the Allegheny spill, we've got to report that. If you drink Pellegrino water, that's 900 TDS, total dissolved solid. If we spill 5 gallons of your Pellegrino water, it becomes a reportable incident to the DEP. Now in other states like Texas, the limit is 20 barrels. A barrel is 42 gallons. So that's 840 gallons. In this state, it's 1 gallon. Fantastic for looking at. So we have a drilling operations. We have a rig, pipe we're going to run. We have a closed loop system. We don't have any reserve pit over here in the back like the old pictures would show you, like some operators have in other states. We're closed loop. So all of the cuttings, we're drilling a hole in the dirt. we're gonna get chewed up dirt back. If you were doing it in wood, you'd get wood shavings back, but we're gonna get ground up dirt. We're gonna get pieces like you have that I gave you, and smaller. And we take those, we capture them, we filter them out of the mud that we're circulating around and drilling with. We put them in this area where we, as part of our filtering operations, or screening operations, we put them in roll-offs that we take to a waste management landfill. Our stuff is high enough quality that they use that instead of buying topsoil to do the layer. If you know something about waste management with landfills, every so many feet, they've got to put another layer of topsoil on. Our cuttings qualify to be that topsoil, saving using good topsoil in a landfill. That's some of the drilling. You're going to see some more from Steve on a little bit of that. Protecting the groundwater. This is a quote from the Environmental Defense Fund. The Environmental Defense Fund is not a pro-industry group. I can promise you that. Arkansas, Pennsylvania, Ohio, and Texas, each of these states have enacted regulations to advance best practice for well integrity. The two places we have to worry about groundwater protection is well bore construction. Can it leak from the well, and are we going to have spills? EDF, or many other people say in Pennsylvania, the leaking from the well is not a concern. Their website is edf.org. That is straight from one of their web pages. So we're going to drill the well. Sorry, I'm going to back up. I'm missing things. The way we protect the groundwater. When we first start, we will set 24 or 26 inch casing in the ground. We'll get an auger rig, we'll make a hole, and we'll put it in the ground, line it up vertical, and we will grout cement all the way around. That's what we're starting. It's called conductor pipe. The next string that we do is we'll hook up to the conductor pipe and put a buoy line on, so that we use the air to drill with, but the air doesn't just blow onto the floor of the rig, it goes off to the side. All of our operations include a filter and igniter system, so that if we hit any gas, it automatically goes to a flare and is ignited. And it goes to a filter system. We don't have dust going all over the countryside. That's not what it was like when I first came here many years ago. That's the way we run our operations. So we're going to set through all of the freshwater zone, we'll set a water stream, usually about 150 feet or whatever it takes. We'll set that inside the other piece of pipe. We will pump cement down inside of that casing, come out around, and we'll keep pumping for that good cement coming out around. So we have got that pipe with cement in the ground, pipe, layer of cement, ground, sealed off all of the fresh water. We'll go down a little further with a smaller bit size, and we'll cover up all of the coal seams. In this state, coal is equal with gas. And so I have to protect the coal. So I put a coal string there. Same thing. I'm going to pump it all the way back around and protect the coal. Next, I'm going to drill down to about 2,000 to 3,000 foot. We call it the intermediate string. Drill down that far. Anything shallower than that is where Colonel Drake found it could cave in. You have to worry about it. He was the first one to come up with the idea of these casing strings to keep the hole integrity so we could drill down further. We'll go down to about 2,000 to 3,000 feet, set our intermediate string. That's where we hook up our blowout preventers. Nothing shallower than that is something we would close on or has enough pressure. All we have to do is, if it has gas, like coal bed methane gas, if it's leaking out, we just need to send it to the flare or to the spark igniter, make sure it's not a problem. Don't let methane out anywhere. So we'll set up our blowout preventer stack. Unlike Macondo, where it's down underneath thousands of feet of water and you can't inspect it, our blowout preventer stacks are right there. You can see them, and they're inspected every tower, every shift. From there, we'll go on down, drill deeper. So we'll use the air rig to drill down till about the kickoff point. So all of this, so we've got all the casing set. When the air rig gets finished, and that's a standard Appalachian rig. These air rigs have been around for a long, long time up here. Other places in the country, the rocks aren't as strong as up here. They're not real rocks. They're more like compacted clays and sands. And you can't use an air. We can't use an air rig to drill it. Here, the rocks are so hard, we can use an air rig to drill it, and it goes very well. So we'll drill down with the air rig. We'll fill the hole full of mud, put a cap on the well, and move on. Horizontal rig will come in. We'll drill down, or we won't drill down. We'll come back, re-enter the well, circulate and condition the mud, and then start to drill that curve. The curve is 600 to 1,000 feet. It's not an instantaneous 90 degrees. The way we do it is we use a mud motor, you see here, that actually has a bend in it. The mud goes down the drill pipe and through rotors, stators. It spins a shaft that the bit's connected to. So nothing turns except the bit. The bit will turn about 140 RPM. So if you think of this bent sub, I've got it, I know exactly where it is. Line it up, and the first we're vertical, and slowly we make that curve. So it's a slow, soft curve we make. And then when we end up lining it up, we'll go back to rotating on the horizontal. If you remember the chunk, the connection between France and England, that was one of these things that had to be perfectly aligned. It couldn't be out of gauge any way whatsoever. When they put the two tunnels together underneath the channel, it had to match up perfectly. We use the same technology to know where we are. I tell on our tours a story and I ask who has a BMW or who has a sedan. If you can take your sedan, roll your front windows down, take it sideways and go a mile out and a mile down, I can go through those open windows and never scratch your car. Now how you buried it without scratching it, I don't know. But that's the kind of precision we have. We know where we are. This isn't a guess. This isn't maybe where we know where we're drilling. Way down here, 6,000 feet or more underground. So we drill a horizontal. All right. The next step is we'll move the rig off, and now it's time to complete the well. What we have is this 5.5-inch pipe. It's all the way down the hole we made, and like all the other strings, we pump cement down. It comes on the outside of the pipe all the way to the surface. So from the surface all the way down to we call it the toe of this horizontal, it's cement encased. It's steel made here in Pennsylvania or Ohio. We use only U.S. steel for our pipe. I have, early on in my career, we would use a lot of Japanese pipe because of quality. I can tell you right now that that's totally flipped around. The only steel I like is domestic pipe, steel for domestic pipe, because of the high quality we have in the U.S. now in our industries. So we come in with completions. We'll come in with pump trucks. We'll have sand silos. These are the trucks that will be on the road. These are sand haulers. They pneumatically unload into these sand silos. We're going to pump water and sand and a few chemicals. We'll talk about that. Before we ever bring all this equipment in, though, to do the completions, the frac job, we're going to prepare the location. If you remember when we had talked about the drilling rig, we had a liner that we laid down so that anything that was spilled on the drilling rig, and I expect them to wash that drilling rig down almost every day. I don't want anything dirty. I want it to look good. It's good housekeeping begets good housekeeping. So we're going to capture all that wash water and everything else. Containment's been there for the drilling rig. When the drilling rig moves off, we get a recycling company to come in, pull up all of the containment, shred it up, and recycle it. We'll resurface up the location, smooth it off with small gravel. So we've got a real nice location. And then we'll lay down a new set of containment, new line. Part of that is to make sure we absolutely don't have any leaks that we don't know about because it's been there for a bit. The other is that this equipment layout is different size and shape than for the drilling rig. And so to make sure that it's going to match up with what we're going to do here, we'll lay out containment that is fit for purpose for this operation. Going back to the picture, we're going to talk about how we do the fracking. What we have is the casings down here, and it's covered with cement inside the hole. We will have a perforating system that will go down in the hole and shoot some holes in the pipe. The holes we shoot are about the size of a dime, and they go about 18 to 24 inches. So they go through the steel, through the cement, into the Marcellus shale. Those are the initiation points. We first do the perforation. We'll do it at 200-foot stages. So we'll start at the very toe. We'll perforate 3 clusters, and the clusters are about this long. So we'll have a number of perforations here, space it out about 60, 70 feet, do another set, all within this 200-foot window. These are perforations, and then we're going to start pumping some water in, just plain water. We'll start to open up the rocks. That pressure will make little cracks in the rock. Once we get the things going enough, we can add some sand. If you'll look in front of you, you'll see 2 samples of sand, 100 mesh and 30-50. The 100 mesh is the consistency of flour. You pop it in the gap, you see it. It's like flour. In dry gas area in the Marcellus, that's the main frac sand we use. If you think about that, how fine it is, all we're trying to do is to make enough crack that one little grain of that can fit in that crack, and when it takes the pressure off, it'll hold it open. So we're not talking about big cracks in the rock. We're talking about microscopic cracks in the rock that we're trying to cause. At the very end of the job, we use the 30-50. When you look at the 30-50, it's nothing like your sandbox sand. It's way finer than that. It's very fine sand, but it's not as fine as the 100 mesh. We'll end up the job with a 30-50, so right around the wellbore, we've got a little bit bigger size sand to help it flow right, help the gas flow into the wellbore. But out of the fractures, that 100 mesh is what we're looking for. So we'll pump the water, and we'll start adding sand, and that's the way we're fracking. We get through that stage, we'll pump down a plug. That plug will seal off that stage, and we'll start again for the next 200 feet. Okay, what goes into the frac fluid, you ask? Mainly it's water and sand. It's 99+% water and sand is what we're putting in. The additives are about 1/4%. If you look at the pie chart, you'll see that we've got friction reducer. That's a surfactant to make it easier to pump with less back pressure. It's more like an ivory soap or some kind of detergent, but it's a surfactant. It's a friction reducer. Breaks down the surface tension of water. We'll have a bacteria. We used to, back up. One of the things we don't want to pump down into the well is sulfate-reducing bacteria. Marcellus shale has iron pyrite in it. You may or may not have a sample that has a little piece. Fool's gold. That contains sulfur. If we pump down sulfate-reducing bacteria into the well, it will eat on that sulfur in the iron pyrite and make sulfuric acid. That's the byproduct. But we don't want that. We don't want it for a lot of reasons. But we don't want to worry long-term about corrosion or anything else. Marcellus gas is very clean gas. There's no corrosive elements whatsoever. It's a wonderful reservoir. So we used to use bactericide to kill the sulfate-reducing bacteria. Now, we end up using naturally occurring bacteria, nitrate-reducing bacteria. And we'll add some bacteria food in there. The nitrate-reducing bacteria will eat the sulfate-reducing bacteria. And when it runs out of sulfate-reducing bacteria to eat, and the food for the nitrate-reducing bacteria dies off. And so we've come up with a way that's the same as what they're now doing in the North Sea. It's a required standard in North Sea for a green completion is to use nitrate-reducing bacteria, which is what we use. Well, we switched from a biocide to a nitrate-reducing bacteria. We use a scale inhibitor. We use the exact same scale inhibitor you drink every day. The same scale inhibitor that your water treatment company puts in your municipal water. We don't put it near as strong as they do, and they put it in very weak, but we use it even less strength. And then we've got some hydrochloric acid brews. When we first start doing the perforations, if we can't get the water flowing easily, we'll put in a spot of acid into the well and let that acid eat on the cement. What's happened is a perforating gun may not have gone through the cement or may have not had a clean enough shot through there. So we'll add a little bit of hydrochloric. The hydrochloric does not work on the Marcellus. It just works on the cement. So the idea is to etch a hole in the cement so we can actually get that water moving and moving quickly. So that's the frac. We do that on each stage. That's the fluid we're using. There isn't some methyl ethyl death or something like that in the water. It's water, sand, friction reducer, nitrate reducing, naturally occurring bacteria, nitrate reducing bacteria, some bacteria food, scale inhibitor, and some uriatic acid. At the concentrations we use it when we pump it in, we transport it around concentrated hydrochloric. Just as when you clean your driveways, when you dilute it down, it's called muriatic acid. You get it at Home Depot or other places. Okay, now we're in production. This, in fact, is at the Bakerstown. That Bakerstown pad is less than 1 mile away from the park. Picture of Bakerstown, Fraser Township. We've got the gas production units. The wells are off in the picture over there. You can see a picture of the wells. This is what's going to be there 40 or 50 years. It's not a drilling rig. It's not a pumping. It's this. It will be here for a long time. You notice over on the side, there's a solar panel. We are one of the top users of solar energy in this Commonwealth. We use it on all of our pads because all of our pads are automated. And we don't have electric power lines to the pads. So we'll generate electricity with solar panels running our RTU system, remote telemetry system. Everything here is designed so that without any electricity, without anything else, all the safety shutdowns are set on an analog fashion. Somebody comes up, does something, twists a knob or anything, everything automatically shuts down. It's fail shut on all of this equipment. Turn it down. We can control from this computer the whole pad, and then this computer talks to our central control room outside of Washington, in which we're watching we can watch all the pressures, flow rates, temperatures on every pad, every well that we have in our operations. All the stuff in Allegheny, Beaver, Butler, and Washington County. We can shut the wells down remotely. We can change the flow rate remotely. But once they're shut down, we may not restart those wells remotely. Somebody has to physically be there to make sure there's not a safety problem. And then we'll turn the wells back on with somebody physically there. Okay, let's again go back to our local activity. Does the council want to develop the gas under Deer Lakes Park? There's activity there anyway. There's activity all around. We and the rest of the industry are developing the gas in the area. The question is not, is there going to be gas development? It's, do you want to take advantage of that gas development for the benefit of the county? Lease bonus, parks fund, royalty payment. So we look at it. Let me catch up here just a second. Okay, we've already talked about the fact that XTO's up here, Rex is over here, our operations. The Bovard, we've got a drilling rig on. The pictures you saw were for the Bakerstown. The Schiller is right here. We've already permitted 3 wells on the Gulick pad. That's represented there. This is the Ute wells that were the first ones we drilled just outside of the mall. We look at this area, we have an AMI, an area of mutual interest with Huntley and Huntley. We have an agreement that within the outline of this area, anything either one of us acquires, will be put together. We will have 75% of it, and we will be the operator, and Huntley will have 25%. So we're going to be the operator of anything in that area. The yellow represents leases that we already have in the area. One of the questions that got asked of me is, well, why did anybody else bid? You know, XTO's here and they're moving north. Rex is here. We've got all the leases in here. We obviously are the ones, if you want it developed. Hope you believed everything I told you about how much attention we pay to our operations. We're also in the area, so we can drill. Now, can you get somebody else to develop it? Absolutely. But if we've got this tied up and there are no drilling locations here, and I don't know that there aren't, the only way for somebody to develop it in later time is to actually drill from the park itself. We'll have leases off the park. We can drill from off the park to help develop. Okay, what would be our plans if we get this lease? The plans are, in addition to the 3 Gulick wells we already have planned to drill, initially we would plan on 5 wells going to the northeast. These would be long horizontal wells, and we would turn these on. These wells will fill up our pipeline system. Those wells will have enough production that we will delay drilling other wells in the area because it won't do me any good to spend that money drilling and not be able to produce it. This would fill it up. If we don't drill these wells, we're going to drill other wells and fill up the pipeline. But we're going to be active in the area. This map shows the roads, the main roads we'd be using, the other roads, and the creeks. If you remember from one of the maps, I think some of you have seen, maybe all of you have seen, there's a creek right here. If we have any kind of surface spill in this area, it would go to the creek and on. It's pretty hard to go down to the creek and up the hill. So on a surface spill itself, there would not be anything getting into the park simply because it's a different elevation. As I showed on the previous map, we already have operations right in here anyway. We are there. There is development surrounding the park. Okay, let me turn it over to Pete. As I said, we believe the EDF speaks very strongly. You have to protect groundwater. The way to do it is make sure wellbore construction is proper, and in this state, it's already in place. The other is handling spills. Pete, you want to talk about handling water?
My name is Pete Miller. I'm the Water Resources Manager at Range Resources. I'll give you an overview of the proposed water operations for this area. First and foremost, we're very proud, as John said, of our 100% recycle and reuse. In 2013, we essentially used 100% of our flowback and produced water. That, as John said, so that makes about 29% of our total water usage for the year last year, and we expect that trend to continue throughout the next few years. For that 29% that we use the flowback and produced water for, we don't have to take any water out from the other sources, which would be municipal water and surface waters. So for this well in particular, the primary water sources we plan on using are going to be municipal sources. We currently have 2 municipal water sources permitted with Fawn Fraser Joint Water Authority, and those are out of meter vaults, which are really similar to this bottom left-hand picture. And then we also have one municipal water source permitted with Oakmont Water as well, which is in close proximity to the area. As a fallback, we also have a large water source permitted on the Allegheny River, which is down in Springdale, right next to the Lampus Block area. So that would be the fallback solution. Or if we get extra water for the wells. The water from those vaults, and if we do use the Allegheny River source, would be transported, or if it's in the vaults, we actually pump it to them. We wouldn't even use a truck. We basically pipe it directly to large temporary freshwater storage tanks. And these freshwater storage tanks would be located primarily on 3 existing pads we already have in the area and that are already built and that we've used previously for development of wells in the past. We're also exploring other temporary surface leases with other landholders in the area that possibly hold more of these water tanks. Just to give you an idea, we probably put one of these each on those pads, and these are 41,000 barrels or about 1.7 million gallons each. And what we do is we pre-fill these before the frac. So we set these up a month or two before the frac, turn those municipal sources on. It's not necessarily a large rate of water, but it's usually 120 to 250 gallons a minute. And we'll just turn the faucet on, basically let these fill up for a month ahead of time, and then we're ready to use them, we'll use them. We use them at a much quicker rate than that, so we have to pre-stage this water and use it. From those tanks, we lay a temporary surface line to the well location. And we primarily use HDPE. As I said, this would be only carrying fresh water for this well pad. The distance of these pipelines, we're expecting to be about 1.5 miles. It's all done through surface lease agreements with landowners. As you can see, it's very low impact. What they do is they weld these together and string them together in large sections, and then you go pulling or pushing across land. So the only real disturbance would be from the pipe going across. And there'll be some areas where there'll be some bulldozer activity where they're really pushing it, pulling it, but we try to keep that to a minimum. As I said, it's HDPE. It's laid out by an engineer, and they take into account everything, the flow rate, the rise, the run. And even though it's a temporary system, it's engineered like a permanent system. It is also pressure tested, just like you would on a permanent system within a plant. From start to finish, we lay it out. It takes about 2 to 3 weeks to lay it out, so there'll be some activity, and then we try to do it right before the completion of the fracking of the well. During the fracking of the well, this pad would take anywhere from 3 to 4 weeks, so it would be in operation during that time. And then immediately after it was completed, you would basically pull in, demote, and remove this pipe. And that would take about another 2 weeks to accomplish. During the operation of the pipe, we have basically 24/7 monitoring of this pipe. So we'll do daily full inspections of the pipe. Sometimes hourly, depending upon the areas. If we have stream crossings and road crossings, we'll check on those more frequently. The service companies manning the pumps, meaning where the water comes from and out of those areas, will be their 24/7 staff. We'll also have security at the well pads, both at the well pad where the water is being delivered and where it's coming from, those large tanks as well. And essentially, we treat all pipes the same way as carrying fresh water or reuse water. We treat them the same, we test them the same, we engineer them the same. For this pad, we will be using reuse water on this pad, but it will be strictly from the wells that are within the area itself. So the 4 pads that we already have within this geographic area, we'll be hauling the produced water, which is basically the return water that's coming back at a very low rate. It'll be trucked into the pad that we're proposing here to drill and offloaded in tanks similar to these. And you can see there'll actually be fewer tanks, most likely 3 tanks. As you can see, they're lined. Trucks will back up, offload in those tanks. There's actually people there to supervise them, make sure they're unloading correctly. And just to give you an idea, the pads within this area in March averaged producing 1.5 trucks of water a day. So it's a very low rate. This geographic area typically doesn't give out much water when it comes back. So we're at a very low rate. So the reuse on this pad is going to be a little lower compared to our other pads that we have in Washington County that usually produce a little bit more water. We will not be bringing water out from Washington County to use in these wells or any of our other areas. It doesn't make economic sense for us. And we can use that water down there as well. We're also going to have activity in that area as we're completing this well as well. The trucks that do deliver this and the trucks that are picking this water up even today as we speak, they are delivering it down to Washington County. So this is actually shortening the trip. So they'll be driving basically a mile or 2 rather than down into Washington County. And all of our trucks are equipped, and all of our trucking companies, we don't actually own trucks, but we have agreements with trucking companies. They're equipped with GPS systems and tracking systems, so we can tell exactly where the truck is, how fast it's going, if it's going on bonded routes, and these are all basically flagged. So if they go straight off a route that they're not supposed to be on, if they're speeding company gets flagged, we get copied as well, and we have very little time for that, and there are a lot of truck drivers that are not working for us at this point, over the past 5 years since we've been doing this. So we keep a pretty tight ship on that. And basically from these tanks, it's pumped directly down hole. So there's a short pipe from here to the well. The tanks accept the water and well pad from there. It goes right down hole for the fracking process. I'll turn it over to Steve Johnson for safety and environmental considerations.
Good afternoon, ladies and gentlemen. I'm Steve Johnson. I'm the Director of EHS Operations for Range. The purpose of my presentation this afternoon is to provide you with some information about Range's commitment to safety and environmental protection, so that it will inform your decision about the ordinance before you. Safety at Range encompasses well-being and protection of not only people, but also the environment and every aspect of our business process. As such, protecting our employees, our contractors, the public, and the environment is a core value at Range. Safety is a process. It's led by the senior management. It's implemented and supervised by our frontline supervisors and managers, and it's followed by all our employees and our contractors. It's a process where at each level, you're accountable to the ones above you, and you're responsible for the ones below you. In last week's hearings, there were some questions raised pertaining to the safety of Range operations. So I'd like to provide you with a little greater detail on why we believe you can be assured that our operations are safe and that your communities and your environment will be safe with Range as your natural gas drilling company. First thing I want to look at, First thing I want to look at is our workforce. Our workforce is trained to be safety conscious. Through training, we provide our employees and contractors with the knowledge and the skills they need to perform their duties effectively and safely. We use a combination of computer-based training, periodic formal classroom training, and tailgate meetings, which are on-the-job site meetings that alert people to hazards and inform everyone about the anticipated operations. We also frequently use what we call safety alerts, which address industry incidents. By calling attention to notable incidents we have that occurred either elsewhere or in our own area of operation, we can educate the workforce and we can head off future occurrences of the same variety. While we employ a large number of contractors to do the work that we do, Range's on-site supervisors manage the company locations. They ensure our processes and our programs are adhered to and that they're conducted safely and effectively. We maintain a stop work protocol on all of our sites throughout our company. This allows any person on any site who sees a situation that is dangerous to people, to the environment, or to the process to stop work, to declare work to stop, to get supervisors to take care of the problem before work continues. And finally, Range's contractor management program is another way that we promote a safe workforce. The program verifies that our contractors have a good safety program, that they train their employees in that program, and it also gives us the opportunity to conduct compliance audits to make sure they're following their own program and that they are meeting our standards. The second area I would like to call your attention to is that of our work sites. Our work sites are designed to be safe for the people who work on them, and by extension, they're safe for your communities as well. Construction of our drilling sites is done in a manner that makes them safe from the very beginning. The surface and the subsurface of our drilling sites consists of multiple layers of compressed dirt, soil, crushed rock, and gravel that will eventually support the heavy equipment and the traffic that will be on those pads. The construction is done in such a way as to preclude erosion and sedimentation, allowing sedimentation into the waterways. The well sites are large enough for all the equipment and the type of work that each phase of our operation requires, whether it's drilling or completions or ultimately the production of the site. The pads, the access roads, the environmental enhancements that are built into our sites are constructed in accordance with the Department of Environmental Protection standards. We submit our plans to the DEP before we build them, and they inspect our site before we begin operations there. Our sites are lined with multiple layers of geosynthetic and polyethylene liner, similar to the liners that are used in state-of-the-art landfills today. The liners remain under the equipment throughout drilling and completions. You can see the liner here under all the equipment associated with this drilling rig. The liner remains under those permanent facilities throughout the operation to catch releases of fluids, to facilitate cleanup of spills into the containment, and also to keep fluids and materials from getting on the ground. In our production sites, all of our tanks are contained in lined containment that has a metal barrier around it. Each one of these containments is designed to hold 110% of the capacity of the largest tank in that battery. Therefore, and that is also lined with plastic liner as well. And the sites also, each pad has a berm around the outside which enhances containment, is another means of containment as well. Our sites are inspected for safety and for operational effectiveness daily by the on-site supervisor. And every week, our erosion and sedimentation inspectors conduct an inspection of every site that we have, and more if it rains, per the DEP's requirements. Chemicals and fuel products that we use on our location are also stored in safe containment areas. They're clearly marked and are managed by people who've been trained. We follow a rigorous hazardous communication protocol, which means we know exactly what's on the site and how much there is and what its characteristics are. The site supervisors maintain safety data sheets on every type of substance that we have on the site. Here's another example of containment for some of the materials that's on the site, and you can see the berm that surrounds that, as well as the type of material that we have. John talked about the closed-loop drilling system that we have. Waste materials or the drill cuttings that come from this are not placed in pits, as he said, but they're captured in roll-off boxes like you see here. They're sampled for analysis. The DEP grants us a permit, and we haul that stuff to a certified landfill to be disposed of. Similarly, Range has implemented, as he pointed out earlier, dust management practices and a zero vapor protocol to minimize air emissions. The drilling rigs are equipped with what's called a vapor destruction unit. They got a little circle around it here. And what that does is it collects the hydrocarbons that are encountered in shallow formations during the drilling and incinerates them before they're released into the atmosphere. There's no emissions with it, and it's safer for workers. In wells such as the ones that are going to be drilled here, or that are being drilled here in Allegheny County, the dry nature of the gas means that there's no vapors, there's no volatile organic compounds that normally accompany products that have natural gas liquids in them. The produced gas is placed directly into the sales line and there's no venting to the atmosphere. Our permanent facilities are equipped with the best operating technologies available. We also routinely inspect this production equipment with meters to verify its integrity. Range uses a FLIR camera, a forward-looking infrared radar camera, to comply with DEP requirements that we inspect every production site before it goes into production, looking for leaks in the production equipment. And we also conduct this inspection once annually to meet DEP requirements. Should we find, this is a FLIR, what a FLIR camera looks like. When you see it, if you would see a leak with this camera, it would be very clear where the leak was coming from, and you could go back and track it down and fix it. Once all of our sites are marked and guarded. Prior to the construction of our sites, we're assigned a 911 address by the local townships, and those addresses are registered in your call center here in Allegheny County. The addresses are displayed at the entrance to the site, and the GPS locations of that site are located on this sign. The sign contains emergency response information and a 24-hour call number for our company. Drilling and completion operations are guarded 24/7 by security guards. And the security guards are there to keep unauthorized people out, to make sure that the traffic that goes in and out of those sites does so safely, and to make sure we have an accurate head count of everybody that's on the site at any given time. The guards and the supervisors on the site also make sure that people wear the appropriate personal protective equipment that is our company's standard. Hard hat, safety glasses, hearing protection, fire-resistant clothing, steel-toed shoes. While we are operating in areas at various points in time, there's considerable traffic that goes in and out of the site. We develop a traffic management plan for each site during these high usage times and when road congestion is possible. Our security coordinator will coordinate those plans with the local emergency management agency, local law enforcement, and he'll keep those agencies informed of our operations and changes to it during the time we're operating. Working with the school districts, we develop a formal restriction to our traffic so that we avoid conflicts with school bus hours. We place traffic monitors, control monitors, electronic speed warning signs, and so forth near our sites to monitor the traffic that's coming to support us, make sure that they're obeying the speed limits and the posted signs. When we complete the drilling and the completions operations, we lock these sites up with gates that have restricted numbers of people who have access to them. And we also continue to manage them by using cyclone fence on the inside to protect our tank batteries from attractive nuisances. The third area that I'd like you to be aware of is how we manage incidents. Companies managing large numbers of vehicles and heavy machinery face potentials of incidents resulting from mechanical and human error. Generally speaking, incidents are primarily fluid spills, personal injuries, and property damage. When they occur, our employees and contractors report. We maintain an internal notification chain that ensures that our supervisors and managers are alerted when people to the nature of incidents that occur. We don't keep secrets. We track reported incidents by using a management system approach, and by taking the incident and identifying the root cause of what caused that incident, looking for corrective actions, and then assigning those corrective actions to be implemented. Notable impacts are communicated throughout not only our own division, but also our company, so that we can educate the workforce and head off those kinds of incidents in the future. We also maintain a series of emergency response plans. John mentioned the preparedness, prevention, and contingency plans, the PPC plan. This is a DEP required plan. It's designed to provide for foreseeable workplace occurrences and provide a framework for response to them. Copies are located in each county. We provide copies to each county, and a copy of each plan is located at each site. Spill prevention and control contingency plans are primarily a requirement of the Environmental Protection Agency. They're primarily positioned or designed to be used for some of the wet gas sites, and the nature of the sites here in Allegheny County don't require an SPCC plan. And the third type is individual response, emergency response plans. We prepare one of these for every unconventional well site, and they're tailored for that particular location. Our plans are pretty simple. On the front side, we show a number of things. It's very difficult to see here, but this is a topographical map. It shows structures, roadways, waterways. It has information about who to contact in an emergency, directions for the nearest hospital, directions to get to the pad. On the back, there is information that applies to what actions employees should take to ward off if there are incidents, likely hazards that could be encountered, critical information for first responders, and also hazardous communication information. These emergency response plans are filed with the DEP, and also we file them with the applicable emergency management agencies in the county. With respect to the county and the township first responders, Range works very hard to establish solid, good working relationships with them. Our security coordinator, who himself is a certified medical technician and also a former fire chief, conducts well-site hazard orientation briefings for fire departments that would like to have them. He's also assisted in the past in getting folks training from the State Fire Academy. And we also have conducted a number of first responder training exercises with the idea of familiarizing our local first responders with our procedures and allowing them to come out and see what kind of situations they could encounter in some of our sites. We've conducted 3 of those in the past 3 years, and we'll continue to do them in the future. We clearly understand the authority that's vested in the senior local official on the site of an emergency. And our people are trained to recognize the authority of the local official. We're trained to provide support, advice, and assistance in time of an emergency. We're prepared as a company to organize ourselves to respond to a major incident using the National Incident Management System and the Incident Command System. I want to touch on a couple final things that these were brought up in the last session. You asked about our performance relative to OSHA. The 2 primary measurements that OSHA provides are the days away restricted and transfers. It is a formula where any of those, person that falls into any of those categories, there's a formula that works it out. The industry standard for DART is 5, and currently in the rolling average that we maintain, ours is 0.0. We haven't had any incidents over the last 12 months. As far as total recordable incident rate, the TRIR, which is another standard that OSHA uses for recordable injuries, the standard is 0.9. Currently, over the last 12 months, our rolling average is 0.3. Our average has been 0.3 for the last 3 years. Talked a little bit about spills earlier, and I'd like to give you a kind of an order of magnitude of spills. This is a fact from 2012. This is data from 2012, and it applies to our company as a whole, all across Range Resources. Up on the top, you can see where it's about. This is the number of barrels of fluid that was transported, 68,700,000 barrels. Of that, we had, in 2012, about 66 reportable spills. That is spills that had to be reported by the departments. And that accounted for about 1,500 barrels of spilled liquid. Now, again, I'm talking across all of Range Resources. If you work that out, 0.002% of the amount of liquid hauled or transferred is what was spilled. Puts it in perspective as to how little was really spilled. The last slide I'll put up here shows our violations here in Pennsylvania, violations of the DEP. This is based on DEP data. What this chart does, it lists all the E&P companies in this area, all of our competitors, shows the number of wells that they have completed and worked on in the last 4 years, and the number of reported violations that the DEP carries. And then do a simple incident rate, and you can see that our rate is significantly lower than our nearest competitor, and significantly lower than all the others on the list. In conclusion, safety of people and the environment are a core value in our company. We create an effective safety culture for our employees and contractors. We design our operations and our sites with safety in mind. And we pay close attention to incidents so that they can be corrected. and prevent it from reoccurring. We have plans in place should the incidents occur, and we're ready for contingencies if it comes to that. Thank you for your attention. And I'm
I'll go ahead.
take that.
Barry Osborne, Vice President of Land for Range Resources, and my primary responsibility is our leasing operations and maintenance of the company. I'm going to keep my comments brief, and I'm sure that there's going to be a lot of questions that you'll have about the lease, and I'll refer those to the Q&A period that we'll have at the end. The lease, we've got a lease here that's, we've taken something that we typically do in 3 pages and have magically transformed it into 81 pages. So it's very comprehensive, and probably, I've been in this business a long time, and it's probably the most comprehensive non-surface use of lease that I have ever been involved in the negotiation of. Now, I'll walk you through some of the moving parts of a lease, because a lot of folks aren't familiar with how an oil and gas lease works. It works much differently than an office lease or an apartment lease or an automobile lease. First of all, you start out with a listing of the parties. In this case, Range Resources is the party. There was a question about, Huntley & Company was originally part of the RFP process, and they're our partner out there. But Range is the operator. We're the party that's responsible, and we're the ones that will have privilege of contract with the county. So it was our name that will be on the lease line. Then there's a description of the premises that's included in the lease. The county park, as you know, was put together, kind of quilted together from a lot of different conveyances and grants and whatnot over the years. We have run title on that. The original approximately 1,180 acres that was included, we have found defects under about 45 acres. So there's about 1,135 acres net that we're going to be leasing. That is the net oil and gas acres that are discussed in the lease. We have that title information. We'll provide, I think we're obligated under the lease to provide that title information to the county. We've already spent $10,000 running the title so that the county now knows what they actually have under the park. Next, another part of that lease is that we split up the description of the surface of the park and the subsurface. So the lease premises is referred to in the lease as the subsurface, whereas Deer Lakes Park is the surface part. Because we have certain surface restrictions, we can't use the surface, but there are certain things that pertain to the surface of the park, so we have carved up that definition into 2 pieces, where when we're talking about maintenance of the surface, we refer to it as Deer Lakes Park. When we talk about the lease premises that we have the right to explore, we're talking about the subsurface. The next the next provision we have in an oil and gas lease is the term. The term is a little bit different in an oil and gas lease than it is in most other types of commercial leases. Here, the term is in this particular lease, is for 5 years, and then there's something called the abandonment clause. 5 years and for so long thereafter as that the wells on the premises are capable of production. This is something that is unique to an oil and gas lease, as you can imagine. When you spend the time and money to develop a lease, you want to be able to maintain that lease as long as there is production or the capability of production. That exists in this lease, just about every oil and gas lease you're going to find. In this case, however, despite the fact that there's a 5-year term, there are some limitations on that, which is a little bit unusual. First of all, there's a requirement that we have to conduct operations within 2 years. And so this isn't a case where we can wait till the end of the 5 years and then move a rig out there on the last day. Operations have to be commenced within 2 years before the lease lapses. There's a second limitation on there, and that's called a Pew clause. A Pew clause is simply a clause in an oil and gas lease, and although it is not particularly common in the state of Pennsylvania, but a Pew clause says that any acreage that is not captured in a unit at the end of the primary term goes back to the lessor. So in this case, we have to develop and unitize all of the acreage within the park in a drilling unit. That means all of the acreage that will be participating in the royalty has to be done by the end of the primary term plus 3 years. It's called the delayed P clause. Okay, the next provision that you see in oil and gas leases is there's the bonus, which is part of one of the commercial terms. Often the bonus is not actually recited in the lease itself. It's recited in a side letter agreement, because typically the negotiation for the bonus amount is something that's, confidential between the parties. In this case, it's actually set out in the lease itself. Now, the bonus is set at $4,000 an acre. However, on top of that bonus, there is the parks fund, which is an additional, I believe, $3 million, which is payable over 5 years. This takes the effective bonus up to over $6,500 an acre. So that is a substantial sum. In fact, that, to my knowledge, is the highest amount that's ever been paid for lease in Allegheny County. The next provision that you see in the lease is the royalty provision, and this is really where the county and lessors make the majority of the money off of the lease. That is the share of production that is owed to the royalty owners that is not reduced by any operating costs. In this case, through negotiations, we have determined there's going to be a cap on the post-production costs, which are going to be chargeable against that royalty. This is an unusual provision. We have it in a few leases that we've entered into, but not very many. And what this does is that it caps the total amount of post-production costs that can be deducted to the 8/8, that means to the entire lease, of 80 cents. I understand there may have been some confusion about how this is determined. That is the royalty is only deducted by, the cap is only to the proportionate share of the royalty, meaning that it's not 80 cents against the royalty. It's only, I believe, I don't know what the math is, it's about 14.4 cents against the royalty. When you calculate in the lease, the royalty is payable against the net proceeds from the lease. That net proceeds is revenue less 80 cents, and then the royalty is applied to that balance. That is a very, actually, it's a very favorable provision, because more often than not, our post-production costs will exceed 80 cents. Then, let's see. Then finally, the last major part of a lease is really the pooling and unitization provision. Pooling and unitization provisions allow this lease to be pooled with other leases in order to develop a unit. Now, this is necessary because when you have horizontal wells, you want to be able to drill as long as you possibly can and capture as much acreage and as much production as you can from all of the acreage that you have leased in the area. This allows for more production, which is more beneficial to all the parties, the royalty owners as well as the operators. A question that I get an awful lot from landowners is, well, do you have to have a well bore under my property for me to participate? The answer is no. What happens when you form a unit of which the county lease or any lease is a part, you have an undivided interest in the whole. It suddenly becomes like one big lease of which you have got a share that is based upon your contribution of surface acres to that lease. So let's say you have a 500-acre unit, 400 acres are contributed by the county, 100 acres are contributed by another landowner that we have that is unitized in there. The royalty of the county will be 400 acres over 500 times their royalty interest of 18%. But they will participate, the county will participate in every single well in which a piece of the county lease is included. Every single unit in which the county lease falls, they will participate in wells building that unit. The commercial terms of the lease are very beneficial to the county. We believe this is the richest lease I have seen entered into in Allegheny County, and I can't even think of one in Washington County that we've entered into that's richer than this particular lease. Like I said, that covers the fundamental moving parts of the lease. I'm sure you're going to have a lot more questions about specifics, but it's 81 pages, and I don't want to flip through everyone and talk about a lot of stuff you're not interested in. So we'll be here for.
Don't leave. I think we've got some questions for you. That pretty well ends our presentation. We thank you for your time. We're really, in my mind, two questions. One, does the county council want to benefit from the development of gas under Deer Lake Park? And two, if you do, is Range Resources the company you want to operate it for?
Thank you, John. I believe this time we're going to let some